Here's a simple bit of code that prints the numbers 1 to 5 to the screen. It works, but it's a bit ugly. Like a blacksmith hammering out each nail by hand, it's slow, repetitive, and a lot of effort for something so simple. Then came the production line, the breakthrough that turned small-scale craftsmanship into high-speed, efficient manufacturing. It took the same task and made it faster, more consistent, and scalable. That's exactly what loops do for your code. They turn a repetitive, soul-destroying task into something much smarter and more powerful. They're like the modern-day production line for your code. In this video, we'll take this clumsy block of code and refactor it into something cleaner, smarter, and more efficient, giving you the power to write more elegant Python. This code is simpler already, but now it only prints the number 1. With just a single extra line of code, I can make this go back to printing 5 or even 100. This is definitely a step in the right direction. It's like moving from a single blacksmith hammering that nail to a basic production line. The while loop keeps going until a specific condition is met, which makes it perfect for counting through a sequence or handling more dynamic situations. Do you remember when we talked about Boolean expressions in the last video? While loops use the same logic as ifs. The loop keeps going as long as count is less than or equal to 5 evaluates to true. Once it becomes false, the loop stops. Like with the if statement, the code that is affected by the loop is indented. A word of warning now, you do have to be careful with these types of loop. It's really easy to accidentally make them run forever. This is called an infinite loop, and it's the bane of programmers both new and old. Can you guess which line, if I forget to add it, would make this code never stop? Pause the video now if you need more time. If you said the increment of count, you were right. If I don't update this in the loop, then the count stays 1, the screen fills with 1s, and my Boolean expression stays true forever. Unlike us developers, Python won't get bored or frustrated and give up. We will have to force the program to terminate with Ctrl-C. That's not the greatest look as we demo our shiny new code. Infinite loops are like a runaway production line. Once it starts, it's not stopping until we hit the big red button. Sometimes you're not just looking at counting. You're working with existing data or generating sequences. This is where the for loop really shines. It's less like a production line and more like a conveyor belt, efficiently processing each item that comes along it, one at a time. Here's how we could do the same thing, print the numbers 1 to 5, using a for loop. The range function here is our production line. This is what Python calls a generator function. More on those in a future video. It basically generates the number range you specify on the fly, just in time for the for loop to need it. One thing to note about the range function is that the end number is not included in the range. So for range 1, 6, we're actually saying start at 1 and go all the way up to 5, 1 before it. Just like a modern production line, this code handles each number in turn without you having to manually manage the counter. It's perfect for iterating over lists, tuples, or any other collection type. Here, if we take out the range function and replace it with a list, you'll see it does exactly the same thing. Basically, it's taking each item from the list one by one and putting it into the variable I for our use. Because these kind of loops are used for each item in a loop, they're sometimes known as for each loops. So when should you use each type of loop? We're going to use a while loop when we want to keep going until a certain condition is met. This is great for flexible, unpredictable loops, like asking the user for a number between 1 and 5 until they finally get it right. And you may have guessed already, we're going to use a for loop when we're iterating over known sets of data or a fixed sequence. It's cleaner, simpler, and often faster. Before we wrap up, just a quick note on performance. In Python, for loops tend to be faster than their while loop counterparts, especially when we're using them exactly what they're designed for, to iterate over data. That's because they're optimized for this kind of task. While loops do still have their place, but do try and avoid those pesky infinite loops. If you've found this video useful, consider subscribing for more tips on writing faster, smarter Python code. And drop a comment if there's any topic you'd like me to cover. In the next video, we'll talk about the basics of reusable code, functions. You'll see this video top left right now. And with that, thanks for watching, and I'll catch you in the next one.